So what can I do instead to make this work? Well, a for loop to do what? But the problem that we had over here was what on the board? Pointing to that same location in memory, right? So we'd have to allocate new memory and then copy the characters over, right? So when you allocated, you'd be pointing to that area, right? Because you would have said like stir.contents equals calloc. So you're pointing to that new area that you allocated, and then you'd have to copy over all the characters. Well, could we be lazy and maybe do something else so that we don't have to like retype some code that we already have, basically? Yeah, we could just do something like return make string of, what's the argument that I should pass in? Orig contents. And that should be an arrow because we're accessing a member. Right? I pass it to my C string that I have. And so I call this function. It does the exact work that we need to do. It would allocate the space, copy over the elements. I could basically rewrite that exact same piece of code, but I'm lazy and I don't like doing that. Any questions here? Yeah. It is not a function we wrote. It's one of the C library functions in the string.h class. And we also wrote it like in class on Friday, which seems to be a while from today. Any other questions? Okay, what about delete string? Yeah. We could use realloc to make the space 0, or we could use free. We could free the space. Normally what you'd want to do though is double check that your pointer is good to the content. So you do something like, if stir arrow contents, then down here we probably would want to do something like free contents. Then we should make contents null just to be safe, and then stir arrow length is equal to 0, right? Or probably like what might be a little bit safer is like -1, because is this C string like really a C string anymore? Not really, because we said it's not a C string anymore, but it's not like our standard string anymore either, because at this point in time, he doesn't actually point to a C string anymore. So we want to kind of signify that he's no longer usable. So that's why he's null, and his length is -1. It shouldn't be reused. Delete should be used like the destructor is going to be used in the destructor is used in C++, as opposed to a function like clear, which removes all the contents. So we might want to write also clear to clear the contents as well. So void clear std string pointer stir. So now the goal here isn't to like delete the string, it's to make it become the empty string. So what should we do here? Yeah. We can. We could just do something like this, like stir arrow contents at 0 is equal to the null character, and then stir arrow length is equal to 0, and now it's the empty string, right? One thing that we might also want to do is maybe realloc the string so that it shrinks down to its new space. So how could we change the size of our string so that it's exactly that one character big to fit the null character? Realloc. So what's it going to look like? Besides a call to realloc somewhere in here. What? So stir arrow contents is equal to, right? Don't forget to reassign whatever realloc gives in case it moves your location of memory around. Stir arrow contents, because that's the pointer that we want to realloc. And then size of a char, right? Or you could always do something like this. If you always do dereference whatever's on the left-hand side of this assignment, it will always 100% be the correct type. Because what's the type of stir arrow contents? Char star. And if you dereference char star, you get a char, so you end up with the size of a char. Or we could explicitly write size of char. But this way, you're never going to get the wrong type. So how could we get the size of our string? Return string arrow length, right? This is just to provide a uniform access so that people don't need to know about our internals to make this all work. Yeah. I'm not using them interchangeably. I'm using them when they need to be. Do you guys remember what arrow is equivalent to? Right, so stir arrow len, that's the equivalent of star, stir, oops, star's in that place, dot len. So when you're using the arrow, it's dereferencing the pointer and then accessing the member, right? So notice these ones have a pointer, a pointer, a pointer, a pointer, a pointer, a string itself. So here I use the dots because I don't need to dereference a pointer because I have the object itself. If you're working in C-line, C-line is really good about automatically fixing that for you. So if you've been typing dot all this time, you may have not noticed it, but like C-line will automatically correct it to be the right thing. So if I do something like stir dot len, oops, maybe I have to, at least it does it in, no, I guess it won't fix it for me here. It does in C++, where it will fix it, my arrows will become dots and my dots become arrows. Okay, so here we want to get the character at the position, so what do? Stir arrow contents pause, right? You just dereference it. And then we also had get char p so that you could get a pointer to that character. So how could we get a pointer to the character at position? No, you still need arrow. Could we do this? I mean, you can kind of see it's like, oh, cannot take the address of an R value type, so that doesn't work. Even if we could, with, let's say we did this instead. We had like a char temp is equal to this, and then we did return the address temp. Does this work? Why not? Temp will be deleted, right? This causes us to copy the value in the array into this other completely different unrelated variable. And then we return the address of this other variable, not the address of the character in the array. So we have stir arrow contents. Ampersand. This will work, right? So we get stir arrow contents at position, right? We get that element, and then we say, hey, give me its address, which is a pointer to that thing. The other option that we could do is this. ++. Right? If we go back to the previous version of the address of stir arrow at pause, what's a way of rewriting the square brackets or doing what the square brackets do without writing them? So how can I write the expression on 53 without the square brackets? Right? This ends up being the address of stir arrow contents plus pause dereference. And what did we talk about ampersand and dereference? What are they to each other? Well, the ampersand means the address of, right? And star means go to that address. So they're inverses of each other, right? So if you dereference something, then take its address, or take its address, then dereference, they cancel out, so you're just left with stir arrow contents plus pause. If you prefer this method, perfectly fine. You're going to get the exact same thing. But because these two guys cancel out, it will be equivalent to stir arrow contents plus pause as well. Okay, now probably the one that you've all been waiting for. How about insert character? So we want to insert a character at a position inside this array. So again, like we want to like insert it, so we want to add it at that position. We don't want to overwrite the character that's there. But hey, if you don't remember, we've already done this before. But with what? Vectors, right? Because you can think of like a string is a vector of characters, right? So we've done that before. So how do we make that work? What's the first thing that we have to do? We have to resize. So how do I resize? We use realloc, right? So we do stir arrow contents is equal to realloc. Stir arrow contents, that's what we're changing. And what should our new size be? Stir arrow length plus 1. Say what? Times size of stir arrow contents. Make sure a multiplication happens correctly. Now, probably not plus 1. But so let's say we want to like insert s into cats. Currently our string size is 3, right? And so if we realloc, will be size 4, which will allow us to put CATS, but what are we missing? The whole character, so plus 2. Make that happen. Extra 1 for the null character if you want, plus 1 plus 1. And then, you could do in the comments plus 1 for the new character, plus 1 for the null character, right? So that you know what's going on, because it could be ambiguous. Why is it plus 2, not plus 1, or why is it plus 1 plus 1? So great, we've resized. It's already there, but is it counted inside of length? So yes, it is there, right? We do have the space for it. It's already stored. We're just not accounting for it in that variable. So our new size has to account for it as well. So that's why it's the plus 2. The other option that we could do is do something like this. We could do stir arrow length is equal, or plus plus. That's 1 more. And then I could take off the plus 1 there. And then you can have that extra +1 as being indicated for the null character. Okay? So we made space. Now what do? Yeah, we take a for loop, we start at the back, and we shuffle everybody over, right? So for int I is equal to, not pause, equal to this, well, we've already +1 the length above, so it should be arrow. So should it be, again, if these things are confusing, what you can always do, draw out a picture for yourself so you know what's going on. Right? Our length started out as being 4. Right? Our length started out as being 3, not 4, because we have cats. And let's say I wanted to, for whatever reason, in between this A and T, I wanted to insert Z. So that would say at position 2 is my insert. So what we've already done so far is we've resized. And our length is equal to 5 at the moment. We only added 1, right, in our code, so it's at 5. So where do I want to start my movement at? Yes, the null character is going to need to end up here at position 5 at the end of the day. Yeah, so we could start at 5, so that would make us start at, well, again, length right now we said is 5, and so we might start at 5, and then we could say, you know, stir at I is equal to stir at I minus 1, the previous thing. And then we want to keep going until we are equal to the above it, so I is greater than pause minus I. And then we could do something like stir arrow contents at I is equal to stir arrow contents at I minus 1. So here we'll start at 5. Is 5 greater than 2? So we copy a null character, right? Is 4 greater than 2? Yes, so we copy over the S. Is 3 greater than 2? So we copy over the T. Is 2 greater than 2? No, so we stop. And now what do we need to do? We change this T into a Z, so stir arrow contents at is equal to, is equal to how? And fantastic, we're done. Did drawing the picture help? That's why you should draw pictures when you're doing your own homework too. It makes life easier, especially for like the linked list problem. Any questions? Okay, so now we have insert. Now what about removing a character at some position? So again, let's say we now wanted to get rid of this character that we had. And so we need to make sure that each character we move over. And so, right, we can start with that for loop. So for int I is equal to pause, right? I is less than. I think we can just do strictly less than length because we do need to move the null character over. Right, and then again, we can just try out our example. So plus plus I, this should be a stir arrow. And then what should be in our body? Right, so if we follow this for loop as we have it written, is 2 less than our length, which is currently 5? Yep, so it becomes the t is 3 less than 5. Is 4 less than 5? Is 5 less than 5? No. And then, what should we do? We should realloc to shrink down. So stir arrow contents is equal to realloc. Again, we're changing stir arrow contents. And what should our new size be? Because again, we need 1, 2, 3, 4, 5 characters. It should just be length right now because we haven't decremented length yet. So stir arrow length, oops, times size of star stir arrow contents. And then we would do stir arrow length minus minus, goes down by 1. All right, we still need space for that null character. It's the easiest thing in the world to figure out. But we only want the first 5 characters, so we'll keep the first 5, and then we'll shrink down to 5. So CATS, this guy now goes away, and then we shrink down to 5, so it's just these 4, and then we change length from 5 to 4. So we're good. Any questions there? Okay, what about pushback character? We can do it easier since we have insert. But if you wanted to write it, we could do the whole pushback, right? But we could do something like, what do we call the function? Insert char. And then we take in the string. And then what position do we want to insert it at? Yeah, how do we get the length? The length, right? So what's our function so that we can be good people? I guess we should probably use something like a string size. I don't know. Stir. And then the value that we want to insert as well. And great, we're done. This should still insert the null character, because again, if we go back up to our example over here, and we scroll back up to insert character, right? So now we're saying that we want to insert at position. We want to insert, we're inserting at our length. Our length is currently 4. So the first thing that we do is we increase length by 1. So length goes up to 5. Then we reallocate space for that new character. Then we start I at stir, I is equal to stir arrow length. I is greater than pause, right? So our current length has already gone up by 1, so it's 5. So the length went up from 4 to 5. We made space. So now this for loop says for I is equal to the length, which is 5. Make space for a new character. I is greater than pause. So we would move the null character over, right? Because is 4 less than 5? I mean, to say, is 5 greater than 4? 5 is greater than 4. 5 is greater than 4, so we'll move the null character over. We'll run the loop once, and then stir at 4, right? The old size is equal to our value, so then the z would end up going here. Yeah, so cool. But again, if you're like ever in doubt about stuff, again, a small, simple example like this will serve you very well instead of being like, I think it will be, or is it +1, -1, not, right? Drawing out the example gives you the insights that you're going to need. And then finally, for pop back, we want to return the character that's at the end of the string, right? So we'd have something like char. It's a pop. So it's going to return the value at the end and also remove it. So the return value is equal to, I guess we had that function. Get char, right? Stir. String size. Stir. -1. It's the last character, right? Because again, we're only counting like the non-empty characters. So again, cat is CAT, its length is 3, 0, 1, 2. 3 minus 2 is 3 minus 1 is 2, so you get your last character, the T in cat. That's our return value, and then how can we now get rid of the last thing? Right, so you call remove character string, and then again, the one that we want to remove is the last one. So thanks, it's gone, and then we can return the value. This is me. Any questions here? Okay, so now here's your new challenge. So hopefully you guys have read over how to read from a file. If you haven't, the thing that you would accept after you've opened the file is a file pointer. You can also reference the standard input using stdin as a file pointer and the standard output using stdout. So I'm going to now include stdio for that. And now let's say we wanted to do something like string . So we want to read the next string that appears in this file, storing the result into std string. One of the things that if you try to use like scanf or fscanf with like %s, that space has to be pre-allocated, right? But in general, you don't know how big that string is going to be. So what we're going to try to do here is read the next string from this file pointer, which again we'll pass in standard in as to read from the keyboard instead in a little bit. But how would we go about reading the next string from this file? Again, the string being the next sequence of non-white space characters that appear here. Yeah. You read one character at a time. Keep making space for that character until we run into white space. The first thing that we have to do though is like skip any leading white space that would be there, and then we can start allocating the space. Because if you do like scanf %s and it's like space Bob, Like the scanf would just skip their leading spaces and then get you the bob. So we need to skip the leading white space. So first step, how do we skip the leading white space? So while what? So like while it's white space, keep going, right? So the way that we're going to read from the file, or again, it's fscanf, and you say, well, where do I want to read from? I want to read from in. What should my format string look like? %C, oops. And then I want to read into char. And so like one thing that we could do is we could totally have this loop that's going to keep accumulating non-white space characters, right? So we could do something like while like is space C, right? Do it again, right? And as soon as we stopped being white space, we would stop reading. Or we could do this. Great. Because what does that space now in there mean? Match with 0 more white space characters. So we're going to skip all the white space characters, right? And get the first non-white space character that's there. So again, it's really useful to know this. So we don't actually have to find this for loop. But now what we want to do is not is space. So we're still going to need to include ctype.h. That should be in triangular brackets. And then we call this char. So while it's not is space, we need to do something for it. And the suggestion was that we needed to make space for our string. So we should have, std string. So here's our string. And now we need to make space for it. So how do I make space for that new character? Do what? Alloc, calloc, realloc, right? Which of those threes do we want to use? Probably like realloc, because we want to keep like resizing to be larger, right? So stir arrow contents, or stir.contents, right? See, it fixed it for me, is equal to realloc, and I'm reallocating stir.contents. And what should my new size be? But it should be like one more than the length, right? So stir arrow contents, or stir.contents plus 1, right? Times the size of stir.contents. What is this? Oh, stir.length, thank you. Does that look good? Yeah.
Why are you using?
I'm just giving the first white space the first time.
What?
The while loop will it will actually stop on the white space because I need to collect the next characters. If I had a space here, I would basically read like I would skip all white space ever, but I need to stop after I encounter white space. So I need to be able to read the white space to know that I got it instead of just skip it. This one needs to not have the space here, otherwise it's going to be wrong. But we only have 2 minutes left, so we can try to go with that over that after class. So at the beginning, though, what is stir's length? Should be 0. What did we say it was? What did we say string's length was? It's undefined, right? It's completely not been said what it should be, right? So that's going to cause issues. So what should we do? So what we could do is we could do this and so like is equal to make empty string. Fantastic, right? Because now our length will start out as being 0, and our contents will start out as being the null character. Technically what's going to be there. So one issue here before, if we hadn't done this, is that since contents wasn't initialized, you can reallocate a null pointer. That's fine. That's valid. If you reallocate a null pointer, reallocate behaves like malloc, right? So if we had set, length equal to be null, it would have been perfectly fine, right? Because then we can reallocate the first time, and then we can keep increasing it as we go on. But if we just leave it as undefined, I don't know what's going to happen because the pointer is pointing somewhere random. So now what should I do with this character that I've gotten? Where do I want to put that character at on my string? Yeah, push back, right? Stir, and then current character, right? We can reuse the stuff that we've already written, but isn't having what do we call this? Oops, this is addressive string because it needs a pointer to it. But doesn't this make it easier having these little helper functions that are able to take care of our job for us, so we don't have to worry about what's going on? Right? We can just, push back. Yeah, that's totally simple. That makes sense. But remember, push back is all of this stuff. Push back is this, which is basically this, right? Would you want to have this for loop now inside this other for loop? No, it's going to make it a lot more complicated, a lot harder to understand. And this is, again, while writing functions makes your life easier if you break the problems down. That's why, like, in your current homework, there's a read line function, right, that if you implement will make your life easier. Because if that function worked and it could read a single line, what would your read lines function look like? Every time you get a line back, right, add it to the end, right? You just keep calling read line over and over again. It made your problem a lot simpler. But again, you can hide that complexity in the other function call. And then now all we have to do down here is return stir, and great, we're done. I've now read a string of any length, right? It looks simple, but again, that's because we have all these other nice functions to help us out. I will see you guys here tonight.